in this video, we are going to talk about matrices. What is matrices? What are the types of matrices? What mathematical operations can be used on matrices? So what is matrices? Any arrangement in rows and column is called as a matrices. Horizontal represents row, vertical represents column. So this is row 1, second row, third row. This is first column, second column. Always matrix is denoted by a capital letter. Let us take A, and it is enclosed in a square bracket. The dimension of a matrix is denoted as row first and then column. So we have 3 rows over here and 2 columns. So the dimension of A matrix, is 3 rows and 2 columns. All the intersecting points here are the elements. These are called elements. And it is represented as, since it's in first row and first column, so it is E11. We'll talk about this. It's in first row and second column. So always it's row first and then column. Let us take this one. We have over here, it's in second row, second column. Let's take about this. It's in third row and second column. So this is called as a matrices. This arrangement is called as a matrices. Now we'll talk about the types of matrices. There are 2 types of matrices. One is rectangular and another one is square. Now what is the difference between square and a rectangular? When the number of rows and number of columns are not equal, that time it is a rectangular matrix. Similarly, when we have number of rows and number of columns which are equal, that means it's a square matrix. Okay, so that means if we have a dimension of a matrix which has 3 rows and 2 columns, so that means it's a rectangular matrix. But when we talk about square matrix, when we have 2 cross 2, 3 cross 3, 4 cross 4, all these dimensions comes under square matrix. There is one more difference. Let me take one example. If I have 2 rows, and 3 columns, and here I have 2 rows and 2 columns. Now, if I want to connect these corners, with including the elements. So here, see, A gets connected, then D gets connected, and from D, so that means I can form a diagonal over here. But when I talk about this matrix, if I connect this, then this, now I'm not able to, I can't connect, I can connect, but it will be not in the slant line, it's a straight line. So that means diagonal cannot be formed in rectangular matrix. Hope you all understood what is the difference between rectangular and a square matrix. Now let us take rectangular matrix. In rectangular, we have 2 major types. One is row and another one is column. Now what is the difference between these 2? In row, we have only A, B, C. So that means how many rows is there? Only 1 row is there. But how many columns are there? Column 1, column 2, column 3. So whenever a matrix which has a dimension as 1 row and many columns, can be n number of columns. So that time it is called as a row matrix. But when we have A, B, C, here you can see we have only column 1, but here we have row 1, row 2, row 3. So when the dimension of a matrix, let us say B has, it can be m number of rows, but only 1 column. So when we have 1 row, row matrix, when we have 1 column, it is column matrix, and both come under rectangular matrix as the number of rows and number of columns are not same. Now, let us talk about the square matrix. The first important type is diagonal matrix. When I talk about diagonal matrix, in diagonal matrix, this is, let me take a diagonal. This is the diagonal. So that means all the diagonal elements are non-zero. That means I'm having a diagonal over here, but non-diagonal elements are zero. So I've taken an example of 3 cross 3. So the diagonal elements are non-zero and other non-diagonal elements are zero. That means non-diagonal elements are zero. That means it's a diagonal matrix. Now I'll take in diagonal if all the diagonal elements are same. If all the diagonal elements are same. Let me take one example. That means if I have A, and all non-diagonal elements are zero, that means it's a scalar matrix, except 1 and 0, except 1 and 0, because there is another term for 1 and 0. So here, that means non-diagonal elements are 0, as well as diagonal elements are same. Diagonal elements are same. Okay. So whenever diagonal elements are same, that means it's a scalar matrix. Okay. Now, if suppose we have the same diagonal elements, but so we have an identity matrix. What is identity? It is also called as a unit matrix. As I told, one can be used for one, there is another name. So when I have a diagonal which has 1, 1, 1, and so that means this is called as an identity matrix. So over here again, non-diagonal elements are 0 and diagonal elements are 1. So that time it is called as an identity matrix. There are two more types of this square matrix. One is upper triangular. The name itself will make you understand upper triangular and lower triangular. When I say upper, that means there is something, triangle is formed upper side, and when I say lower, that means a triangle is formed lower side. Now again, it's an example of a square. So that means we have a diagonal. So let me form a diagonal. But when I have, that means a triangle, upper means a triangle has been formed on upper side. Triangle has been formed on upper side, and here the triangle has been formed in the lower side. That means all the elements on the lower side over here is 0, and on this upper side is 0. So that means here I'm having an element as A. I'll take anything E, F, G. Here also I'm having E, F, G. So that means the triangle has been formed upper side, and here it is formed lower side. So this is all about your upper triangular and lower triangular. There's one more matrix which can be either rectangular or a square. It depends upon the dimension. There is a null matrix. What do you mean by null matrix? Null matrix when all elements are 0. When all elements are 0. The dimension can be in rectangular form or it can be in a, so that means I'm having 0, 0, 0. This is 2 cross 2 square matrix. When I'm having 0, 0, 0, 0, 0, 0, it's a null matrix with a dimension of 2 rows and 3 columns. See, so it can come under square when the dimension is this. It can come under rectangular when we have 2 cross 3. So this is called as a null matrix. Now we'll talk about the mathematical operations. First, we'll talk about addition. Addition as well as subtraction. In this video, we are just going to talk when we can add and subtract 2 matrices. So I have a 2 matrix A and B. So when the dimension of A is 2 cross 3, as well as the dimension of B is 2 cross 3, that means if the dimensions are same, That means I can add and subtract. Let me take one more example. If I have C and D, the dimension of C is 2 cross 2 and the dimension of D is 2 cross 3. Is the dimension same? No, the dimension is not same. That means addition and subtraction. Here I can add or subtract, but here I cannot add or subtract. Here I can add and subtract, but here I cannot add and subtract. So in the next video, I'll just make you all understand how to add and subtract two matrices. We'll talk about one scalar multiplication as well in this video. What do you mean by scalar multiplication? In scalar multiplication, when I talk about scalar multiplication, let me take example for it. So if I have a matrix which has 1, 2, 3, 4, 5, 6. So any number, it can be a fraction, it can be a decimal number, it can be any number. Let me take as 2. So this is a scalar number. So that scalar number, when I multiply inside a matrix, it will be multiplied with each and every element. Let us look in the example. So when I take 2 inside, it will be 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10, 2 6s are 12. So this 2 is multiplied with each and every element inside the matrix. So this is nothing but it's a scalar multiplication. Now the last one we are going to talk about is multiplication. An example will be taken in the next video because this multiplication itself is a big topic. Let me take one example. If I have a matrix A with the dimension as 2 cross 3 and B with the dimension as 3 cross 3. So if I multiply A into B, so now let us check how to always make a habit to write it in this manner. Do not change the position. Why? I will let you all know. Okay. Now, always you have to look over here. With the first matrix, look in the column. For the second matrix, look into the row. Here the column, here it is the row. These should be same. If it is same, that means it exists. Let us take this example. I have BA. As I told you all, do not change the position. So B, the dimension is this, and A, the dimension is this. Always look to the neighboring numbers. This is the neighboring numbers. These are the neighboring numbers. This is a column and this is row over here. Are they equal? No. That means it does not exist. Okay. So this is the rule which is applied for multiplication. Thank you, everyone, for listening to me.